Okay, let's do this. Hello back. Welcome. Good afternoon. My name is Bernd Rücker. I want to talk about complex event flows in distributed systems. What I basically want to do is looking at three kind of myths or kind of conceptions I see in the market a lot at the moment. So the first is, and you probably also see that at this event, is that a lot of people are talking about events and event-driven being kind of the silver bullet nowadays. It's decoupling everything, and it's just great to do event-driven. So I want to look at that first. The second is and that very often goes hand in hand, that if you do event-driven and you want to decouple, you should avoid orchestration. You should go for something which is called choreography. I explain that in a second. And then the third thing is okay, and please don't use these BPM or workflow tools from the past, right? Because they doesn't fit into that picture at all. And these are things I see in the market a lot, and I want to go over that in order to check that. Of course, I'm a human being, so I have my own opinion, and I want to just make it transparent that you know what what's my background. So I'm co-founded a company. We are an open source workflow vendor, but I'm basically working with workflow engines for more or less all my professional life. So I contributed to a couple of different open source engines in the past. But that also means that I'm normally, if I see a problem, I look to the problem through the lenses of workflow engine. I'm always looking for state machines and workflow engines. That's kind of my personal background, and probably good to have that in mind when we go through the talk. If you want to send me an email, if you have questions later on, either ask me after the talk or send me an email, tweet me. We're good to answer anything afterwards. I'm an example person, so I want to use an example today, and the example today is motivated by one of our customers. In this case, it's Zalando. I think they're active in France as well, so you probably know them. They're shipping clothes and shoes and these kind of things. And what they have in the background is, of course, an order fulfillment workflow, a business process. Like you order something and you get it, right? That's what they're doing. And they talked about that at a meetup in Berlin more or less 2 years back. So I have 1 or 2 slides from there. And that's basically the example I want to use for today, but I make it a bit more simplistic, so I can use it in the talk. So what I use today is it's a so-called dash button. Not sure if you know the dash button, Amazon Dash. What it does is you can put it next to the washing powder. Hey, washing powder is empty. You just press the button and you get 1 box of washing powder ordered at Amazon. That's the idea. So it's a very easy order fulfillment workflow. But in the background, it's a typical thing. You press the button, you order something. The next thing that happens, you have to pay for it, obviously. Then they have to fetch it somewhere from a warehouse, put it in a box, and send it to you, right? That's order fulfillment. That's a workflow that has to happen in the background in order to get that done. If you look at the modern system, and we're here at the Microservices day, so that's probably not so surprising. You might work with different services, or if you're into DDD, domain-driven design, you might work with different contexts, for example, the checkout service, which is responsible to communicate with that dash button, and then you have probably the payment service, which should retrieve the money, and you probably have the inventory service, which handles the stock, and the shipment to send the boxes, okay? That's relatively easy. That might be microservices in your case. And I don't want to define microservices. I just want to hint to one thing which is important later on. So I just want to put that first. What I see important for microservices, autonomy. So if you have these different microservices, they're having their own database, their own data source, so they don't share a database. They're running in their own environment, so their own application, whatever, Docker image, VM, whatever that is for you. And an own team cares about that and deploys it, right? So you're not having 2 teams working on one service, okay? That's for me, that's sufficient for defining microservices for now. Let's look at how events decrease coupling. Let's make a very simple example, and it's actually not a real feature of the dash button. For the sake of the argument, let's assume you push the button and it quickly blinks if everything is on stock, and it can be shipped to you in 24 hours. Okay? If we want to do that, the checkout microservice communicates with the button. So this service needs to know if everything is on stock or not. But the knowledge, what's on stock, is in the inventory service. The inventory service has the database of what's on stock or not. So the naive, without saying that's bad, but the naive implementation normally is like, okay, you ask for it. Like you ask for the information. You say, hey, I want to know if that's on stock, and you basically do request response, get back an answer, and then it can blink or not. And that's very often HTTP, but it could also be like messaging, like request and response message. The thing is, now you have some degree of coupling, right? Now you have a temporal coupling. If the inventory service is not available, you can't answer the question if something is on stock. If you have a lot of load on the checkout service, you have the same load at least on the inventory service as well, and a couple of other things. So they're in a way temporally coupled, right? So that's the disadvantage of it. Doesn't have to be too bad, but it's the disadvantage. What could be an alternative if we look at how we can do that with basically event-driven? It would work a bit different. So we could say the inventory service emits events whenever something happens. Hey, we have new goods on stock, or we just sent something out, so it's gone. And then it emits events to kind of an event bus. It doesn't know who is interested in that information. It just says, hey, world, something happened. And then the checkout service could say, hey, yeah, I'm interested in that, reads all these events and builds an own local model of what's on stock or not, right? It's kind of a cache. You can imagine it like that, okay? And then now the checkout service can answer the question immediately, like, hey, it's in stock. Yeah, I know that in my local model, right? And it doesn't need to ask. It's not coupled in that sense anymore. The price you pay is, okay, it's added complexity, but it's also eventually consistent. So you might lack a couple of milliseconds. You might be behind. You probably haven't fetched some events yet. So you probably give a wrong answer. That's the price you pay here. So that's event-driven in a very quick nutshell here for this scenario. To give you another example where it could really make sense in that scenario is like you could think of creating a notification service somewhere in the architecture and saying, hey, all these other services, they emit events like, hey, the order was placed, the order was paid, and so on and so forth. And then this listens to all of these events in order to send out notifications to the customer, like text messages, hey, your order was shipped, or emails, or whatever. What's the advantage? Here it's clearly that you can like really have all the logic you need in one place, right? So you don't have to think about where on the left-hand side you send out these emails, or if they are GDPR compliant, or what's the configuration, like what the customer wants to have as a notification, do he wants to have whatever, email, Slack, text messages, so you can really have that in one place. So that's kind of a good example of using this event-driven approach from my perspective here. The thing is, now we have this event-driven, and it does decrease coupling in certain scenarios. So there are certain things which are really good about that. And now, as always, people have that new tool, that hammer. Now they use that for everyone, for everything. And what I saw a lot, actually, is that you use these event coupling mechanisms to do what I call an event chain. So let's assume you want to implement that overall workflow of I order, I get it. You could do that with event notification. So you could imagine that whenever somebody clicks the button, an event is emitted. Hey, the order was placed. I tell the world the order is placed. I don't know what happens. I don't care, but the world knows. And that means like the payment service could listen to that and say, hey, okay, there was an order placed. So the first thing I have to do is I have to retrieve the payment, like whatever, charge the credit card. And whenever I've done that, I emit another event. Hey, the payment was received. And then the inventory service knows, oh, if there was payment received, I have to fetch goods from stock. Then the goods were received, and probably, and so on and so forth, right? So you could implement that whole workflow by event notifications or by these event-driven couplings. The problem I personally have with that picture is that you really lose sight of what's going on in the system. You can't see how that overall workflow is implemented. You basically have to look at all the services or the communication during runtime in order to understand that, right? So there's not a single point where you can look at, hey, show me the code, how we do order fulfillment. It's not there, right? I discussed that actually a lot, really a lot over the last years. And what I got in the beginning very often is like, yes, yeah, but you're the workflow guy. You're doing that workflow tool, right? Your tool is not on the slide. Of course you hate it. We understand that, but that's not our problem. And that's why I personally was super, super happy when there was a blog post from Martin Fowler, because he's quite a credible source, for most people at least. And he wrote already in 2017, so that's the link, 2017 January, he said, the danger is it's very easy to make nicely decoupled systems with event notification, that's why we're doing it, without realizing that you're losing sight of a larger scale flow, and thus set yourself up for trouble in future years. And I mean, it's easy to understand. If you don't understand anymore what's going on in your system, you can't change it anymore. What I like about that is Phil Calando had named it this year in New York at the QCon, and he said, we're suffering from pinball machine architecture. He worked at Meetup at that time. I think the term is from Neil Ford originally, but I like that term very much because it's very easy to understand what it means. I made my own slide for that, so this is my pinball architecture. So you just throw in like some event at in the beginning, and then it triggers certain things. And I personally love watching that. So do it again. Sorry, I can't stand that. I love it. And that's the pinball machine architecture, right? And you recognize that by the number of times people ask, what the hell just happened? Why did that happen? How could that? We don't understand it. And that's a big problem, actually. And we see, and now we have 2019, so we see a couple of companies in the past really going, let's say, all in that event-driven approach, like even like startups now having like 200 or 300 microservices communicating in that style, and they don't understand anything anymore. It's really, really hard to see what's going on. I wrote about that also at InfoQ, so just putting the link there, because I'm not going into the details here, but just to name the approaches I normally see to kind of fix this, to understand what's going on. And it's not very surprising, but a lot of people now look at distributed tracing tools. Things like whatever, Jaeger or X-Ray or what is the other one called? Forgot. Zipkin, yes, that's the one actually I use most. That's why I forgot it. It's there on the slide, Zipkin. But that's tracing. What it basically does, it does kind of your call stack, what you probably know from a programming language, in a distributed system. So it passes on certain IDs, put that in every message, and then it can collect that centrally, and you get these nice little flows. What's going on throughout different systems. The thing is, it's very technical. That's a problem. It's very, very deep into the details, and this doesn't normally help you to really understand the flow if there are a lot of services connected. It's a start, but it's normally not what you really need to understand what's going on. Then what I see most people doing is they build something around, I call it data lake or event monitoring. So it's very often something like Elasticsearch. They put in all the events, and then they build something, whatever, on top of Kibana or whatever it is, in order to understand what's going on. If they are good, we had one customer recently doing that, they even add a graphical user interface, like a graphic of the flow there. So it's not totally impossible, but it's things you have to do. But that's actually, at the moment, the most promising approach. The other category of tools, which I personally find very interesting, are process mining tools. What they actually can do is they can read events and then derive the workflow from them. So this is a typical flow, this is an exceptional flow, and they even like show that graphically. The problems with these tools is they're not made for microservices normally. So what they are made for is scanning log files. That's what they're kind of good at. So they're not like, I just connect them to Kafka and I see what's going on. That's not the stage where they are. But let's see what's coming there. And the last thing is like what I call process event monitoring. That's what we're, for example, currently looking at. How can we connect something to some like Kafka or messaging, derive all the events, and then derive kind of a workflow from that. It's kind of a mixture between the middle two. If you're interested, I wrote more details in the article, or ask me later on. The point I'm trying to get at is might get to a stage where you start to understand what you have in front of you. You have all these services. Okay, this is how they communicate at the moment. But it's still super hard, and when you want to change something, it's a bit like having that and saying, hey, yeah, that's all great. We love that pile of services. It looks beautiful. We just need to that steak have to go on top. That's the only change we have to make. How hard can that be, right? And that's a problem we see then. And I make a very easy example with the example that we had from earlier on. Imagine you have that workflow here, like this event flow, and you simply say you want to change like the sequence of steps here, like, hey, fetch the items first before we do the payment. And it's not totally unrealistic to have these kind of changes. They're not happening every day, but you have these kind of sequence changes in reality. I mean, if you look at current systems, my favorite example is Amazon. They sometimes start to fetch items from stock before you even ordered. That's awesome, right? So they do these kind of things, changing these kind of workflows. So if you just want to do this, the thing is, on the left-hand side, just think about it. Now you have the order placed. The next thing that should happen is, okay, inventory has to kick in, right? In order to get things from stock. Then the goods are fetched, and then payments needs to know, oh, goods are fetched, so I have to retrieve payment, and so on and so forth. So what you have to do are these 3 changes, right? And that's pretty bad for several reasons. The first is, it's not only that you have to do the changes, and you have to redeploy 3 services, right? That's kind of not really autonomous, right? You have to change them, redeploy them at the same time. You also have to coordinate it, because you probably have orders circulating around. So you have to think about versioning. Hey, if that was paid, was that in the old version? Then I have to fetch goods, or was it in the new version? Then I have to ship them, and these kind of things. So it's not easy to handle these kind of situations. And it always reminds me, I mean, of this is, one thing I haven't defined. These event flows are typically referred to as choreography, right? That's a choreography. The idea is you don't have a central conductor saying, hey, you're doing that, you're doing that. It's more a choreography in a way that this is the picture which is normally used. And it should be kind of a beautiful dance, right? And like you just add another professional dancer, they know the rules, so they start dancing. We just talked about dancing on stage. Now would be the time, right? But I can't do that. So you add the next professional dancer, and he knows or she knows what to do, and starts dancing. It's beautiful. It's not what I see in real life. Of course you add things, but it's really hard to manage. It's really hard to understand. It's hard to control, right? So this is not what I'm seeing there with choreographies. We did a survey last year, so it's already a bit older, so it's from 2018. It's online if you want to look it up. And the top 2 answers of the challenges in the microservice architectures were lack of visibility into end-to-end business processes that span multiple services, and error handling at the boundaries between microservices. So it's not very surprising, actually. It's just like reinforcing what I just said. Okay. So in this case, what could I do instead? What could I probably do better? I mean, you have to judge yourself, but just the alternative would be to, first of all, to extract the end-to-end responsibility of order fulfillment, probably in a microservice, like the order microservice, like order fulfillment microservice, whatever you want to call it. But now you have a home for that responsibility. And from my perspective, it's always very naive that people are really thinking companies like Zalando let the order fulfillment business process emerge from other things. That's why they are there. That's why they make all the money. Even if they have an internal fight, if order fulfillment or search is more important. Can the people order if they don't find it? But I think order fulfillment is one of these services they need. And then the picture changes a bit, right? It says, hey, probably we still have event-driven coupling there. The dash button still says, hey, something was ordered. I don't care who takes that. But then the order microservice takes that event, says, oh, there was a new order, and now I have to orchestrate others. I have to command others to do something for me. So payment is not reacting on an event, but payment has a clear API where order says, hey, now retrieve the payment for me, please. That's the first thing I want to do. And I wait, for example, till you're done. And that could be probably an event again or not, right? That's an important thing. For me, that's totally intuitive. And some people even ask me, why are you talking about this so long? That's normal. But I see a lot of people not having that as normal in their heads. I think it's very important to make the distinction between like events and commands here. The events, I react to something. Commands means, hey, I want somebody else to do something for me, right? And then you probably send out other commands to the others as well. Important detail here is one, it's not about the protocol, it's not about technology. A lot of people think when I say command, yeah, now you're doing HTTP REST calls again. No, I don't say that. You can do request response, for example. You can use messaging. You can send commands on Kafka. Why not? So it's not about the technology. For me, it's about basically the decision where to couple things. Like in an event-driven coupling here, like this one, right? The recipient knows what events it listens to. So basically, the coupling is on the receiver side. The sender doesn't know anything about who is picking that up. It doesn't need to. So it's on the receiving side. For the commands, basically, the payment doesn't know who is using it. It just knows the API it provides. And the client side is basically where the coupling is. And depending on the communication at hand, the one or the other might be better. There's not a general rule, do it this or that way. You have to decide that for each and every communication. And that's pretty important, actually. Okay, that's commands. As soon as we're there, and we're saying, okay, command, that sounds reasonable. I buy that. I want to use commands. Then you normally get into the next discussion, because commands are orchestration. Now I have somebody telling somebody else to do something. That's a conductor. That's orchestration, not choreography. And then normally, people tend to say, oh, but orchestration is bad, right? We did that like in the earlier days when we had SOA and ESBs, and that didn't work out, right? Yeah, to some extent, but let's look at that in detail. What did not work out? What we did in the SOA wave, like 5 or 10 years back, we had ESBs, which were kind of really big products, relatively smart products. And what we tried to do at that time is basically, very often they had a BPM part as part of the ESB, and then we tried to put the orchestration logic onto that ESB, onto the bus. And that didn't really work for several reasons. It was very complicated, it was to deploy, to test. Very often you had different teams caring about this and that, so you, again, didn't have the autonomy of the microservices teams, and a couple of reasons. So this is the picture a lot of people have in their heads when they think about orchestration. And it doesn't work. I totally agree. I don't like that picture as well. But this is not the picture I had on the slide. What I had on the slide, was, I thought I had a different slide at the next, but what I had on the slide was different. I had the order logic as a separate microservice, not in the ESB as a microservice, right? Come back to that in a second. And then if you read along and if you read the literature, you probably also come again pass by Martin Fowler, and he wrote something in that microservices article probably everybody knows. He said, we want to have smart endpoints and dump pipes. We don't want to have ESBs. They were like smart pipes. Dump pipes, just delivering messages, right? And that's a picture, that's a picture I had. I had the order, like the orchestration logic as a separate microservice. It just means we have a team caring about it. We have a team implementing it, deploying it. For me, that totally makes sense. If you go further, and I really discuss that very often, normally then you probably read Sam Newman's book. He has that O'Reilly microservices book. And he wrote one sentence, and he was quite reluctant to remove it actually in the second edition. But that causes me quite some headache. He wrote, if you do orchestration, you might end up there, like the risk is that a few smart God services tell anemic CRUD services what to do, right? So in the picture, basically this, right? So instead of having like real microservices, you end up with that one like fully bloated, huge service doing everything, and payment is just like CRUD. That's the risk. And I totally understand the risk, but the thing is, it's nothing what happens automatically just because you're doing orchestration. It's something because what happens if you do bad service design. And I give you an example. So if we think of that order microservice, and let's assume we send a command to the payment microservice and say, hey, retrieve the payment for me. And the payment microservice might need another microservice or an external service actually to process credit card payments, right? We can imagine that. So it calls a credit card, gets a response. Let's assume the credit card gets rejected. It's expired, limit, whatever it is. So you get a failure. What you could do, and that's actually what I see a lot of people doing, is you could pass that like, hey, credit card rejected to the order microservice, right? If you do this, then, and then assume you need to implement the following requirement. Somebody says, hey, if the payment gets rejected, we send an email to the customer and saying, hey, your credit card is expired, please update it. Remember, we have the dash button, so we don't have anybody in the UI. And that's what, for example, GitHub is doing. If they extend your account, your credit card expires, send you an email, hey, you have 14 days, update the credit card, right? And if we do that in this design, normally it means that we start implementing that in the order microservice. And that makes it a God service because we move a lot of logic to the order service where it doesn't belong. So microservices is all about thinking who is responsible to deal with certain like requirements. And in this case, it's definitely payment, right? Payment should handle everything about rejected credit cards. Order should never know about credit cards. It only knows about payment. And that means the payment service should have an API where it says, okay, I can retrieve payment for you. And then there are two options. Either I got it or I didn't get it at all. Finally, right? Then we're done. And that's the API you should do. And then you don't end up with God services. The problem I see, or the struggle I see when teams want to go that direction is that because of these kind of requirements, we start to have state in there because we have to wait for people to update their credit cards for 2 weeks. And that's stateful. I mean, of course, we have to save the payment. We have to save the current state that we're waiting for something, right? And that's an additional struggle. And that's actually what my hypothesis is that leads a lot of teams to just not doing it. Just rethrow it. We don't want to have state in our service, right? State is awful. Speaking about state, that's the next thing we want to look at. So, I mean, of course, you can handle state yourself. Shouldn't be too hard. In 2019, starts to get harder, actually, the more we look into serverless and these kind of things. But let's assume do whatever, an entity and persistent actor and document, and there are manifold ways of storing state. The thing is, as soon as you go down that route, you normally end up with implementing a couple of things additionally. Like, as soon as you have something waiting, you need a scheduler, which probably kicks in if it's waiting for too long. You need monitoring in order to understand it. You need versioning. That's what I talked about earlier on. If you change the procedure and still something waits, what should happen with that one, right? You probably want to have visibility. You need to do that scalable. So it's not that easy to do it, actually. And that's why that's my personal bias again. But that's why I think state machines or workflow engines should be at play here. The thing is, as soon as I normally introduce that, people are like, oh, workflow engines, really? These BPM tools from the past? That's what you propose here. That's weird. They're like really complex things. They're decentralized things. They're in the same bucket as these ESBs, which are kind of evil. And this is actually not really true. The thing is, it might be true for some of the tools, and probably all know that or have experienced that in the past. It's these, I call them low-code tools. So the idea of these tools is very often, hey, you can click together the workflow without involving IT. That's how all these tools were, most of them at least, were sold in the past. And that, surprise, surprise, didn't really work out, right? And I call that normally death by properties panel. It's a bit like if you want to do something and you have to follow along a 3 minutes YouTube tutorial to click through wizards, that's a wrong approach, right? You want to copy and paste something from GitHub, right? So, but these tools are pretty bad, and they really burn the place a bit for workflow engines. But if you look at the market at the moment, and that's what I personally do basically every day, it's quite interesting. There's a lot of movement. It's very often not called workflow engine, but we're start to get back to that term. So like cloud, if you look at the cloud vendors, all of them have kind of a workflow engine. For AWS, it's step functions. For Azure, it's durable functions. The others have something as well. If you look at Silicon Valley, they do something like Uber Cadence, open source workflow engine, or Netflix Conductor, or Airbnb did Apache Airflow, which is not really directly a workflow engine, but connected. So they all do something in that stack. And if you look at the open source stack, there are a couple of tools available. There are even more. So I just put a couple of them on the slide here, especially in the Java space. Still, Java space is one of the most active ones there. And there, I put lightweight there, and lightweight is kind of an overloaded term. So I wanted to dive into what I mean by lightweight. And as I'm really short on time today, I hate having code on slide. I literally hate that. I'm happy to walk you through code on in real life after the talk, but for today we have to live with the slide. But I wanted to have a bit of code that you understand what I mean by lightweight. And I used a Java example. I'm not sure who's, probably most people here are Java. And I used the Camunda engine, which is by coincidence the one we do. But it's comparable to some of the others as well. So, and if you look at that code, you could, for example, build a process engine in one line of code with the default configuration in memory H2 engine, probably not what you have in production, but very easy to get started. And then you can create workflows. And a lot of people normally look at workflows on the graphical level. And that's actually what most people really do in real life. So there's also graphical modeler, which you can use. But you can also define it in code if you prefer. And I like starting with that one because a lot of developers are normally kind of really afraid of these models. There might be something hidden or some magic or whatever. So that's exactly the same. So in the background, if you use that code, in the background we generate even the graphical model. But that basically means, okay, I create a new workflow, and then I start it somewhere. I do two things, which is called a service task and an end event, which basically ends everything. And what I use here is the language is BPMN. It's called Business Process Model and Notation. It's an ISO standard. That's why it's so interesting. So it's not a proprietary thing. Different tools understand that. It's a very powerful language. So I personally really like BPMN. And then you can attach code to that. So I could say, hey, the first step what I do is for example, the Java code below there, right? And that's the simplest example of something like really a Java class attached. But you could use Spring Beans. If you're not in Java, you can basically pubs up to the workflow instance to define that in any programming language you like. So there are a couple of things you can do. And then you kick off new workflow instances, and then they run and they're persisted. So my idea just was to give you an idea what I mean by lightweight. So it's not totally complicated to do these kind of things, right? And then you have a state machine. And then you can do things like what I explained earlier on. You can have something like, hey, I want to charge the credit card. That's what I try to do. And if it's rejected, I probably send an email to the customer, however I do that. And then I wait for the customer to update the card. That might be an event I'm waiting for. Depends on a couple of things again. And that waiting is now persistent. Right. Depending on the workflow engine, it might be, most of them use a relational database, Camunda as well. There are others like CB, it's another open source project we do there. We use kind of an event sourcing approach underneath to make it more scalable. Like if you look at Netflix, they use DynamoDB. So there are different options there, but they persisted. It's stored. It's safe, right? And we can go on from there. And then you also have the notion of time and can model something like, okay, if I wait too long, I just raise a payment failed, for example, right? And you can easily express these kind of workflows and then execute them. And that's quite neat, actually, and especially because we're in microservices, we're in distributed systems. I personally always use that metaphor for distributed systems. So that small hut over there, that's your one Java microservice, for example, like your one program. You know what's going on there. It's quite easy, relatively easy to do. You have transaction management, so on and so forth. When you open the door, you meet that rough ocean, and the rough ocean is the network. The network is quite unreliable, and it can do weird things, actually, to you. And you have to take that into account when you build systems with microservices. And just make another example, same environment. Let's say you use some existing credit card service in the internet, and you call that via REST API. And let's assume, surprise, surprise, it doesn't work. You get a network error. You also have to plan for that. You have to take that into account. And the same thing, what I see a lot of people doing now is, because they don't have the ability to store state in the payment service, they just pass it on. Like, oh, exception, I just rethrow it, right? And then it's a problem of the order service. Now it has to handle connection issues with a credit card. That's weird. It shouldn't do that. It's a wrong responsibility. So you want to handle that, then again, it gets kind of a God service. You want to handle that within payment. And surprisingly, we have more and more use cases. I see that at customers a lot, actually, that they have relatively simple workflows just for example, what I call stateful retrying. Because now you can wait even for days, if you like, or at least for hours for the credit card service to come back online again, for example, and retry things. And it doesn't stop there. Or you can do it asynchronously, of course. If you send out a message, you have the same problems to solve. Probably you don't get a response. So you have to wait for the response, and probably at some point in time you want to give up waiting for the response. And again, if it's not milliseconds, you can't let a thread sleep for that time. You want to persist it somewhere where it's safe. Okay. But it goes on, and that's actually my favorite thing. We're still distributed systems, right? And one of the really ugly characteristics is if you get a network error, like just described, 3 different scenarios could just have happened, right? It could be that you never reached the service provider. The internet was just not available, and you never reached it, network exception, okay. But it could be that you reached it, it started processing your request, and then the server exploded for whatever reason. Did it commit its transaction? You have no idea. Or probably it committed everything, it's perfectly fine, but the response got lost. And that can happen with REST, it can happen with messaging. And the thing is, whenever you get that network exception, you have no idea what just happened. If you send out a message and you never get a response, you have no idea what just happened. And you have to plan for that. You have to understand these kind of scenarios. And in this case, you could do something like, hey, I do that, what I call the stateful retrying for a couple of times, but then at some point in time you give up. It's not going to work. But then you probably raise a payment failed event. But the thing is, you still have to clean up something like whatever, issue a refund or ask the credit card service if it has like charged something or not, right? I deliberately made this sequence here. So I said, hey, I want to raise the payment failed event because then the workflow can go on. But then I make sure I clean up afterwards. And as this service was not very responsible the first time, it might not be very responsible when I call it here. But again, it's stateful, so I really can wait for that to happen, right? And that normally removes the burden of having a lot of like whatever batch jobs or reconciliation jobs which run and find these kind of really weird errors, or customers complaining. They're normally not that relaxed if you charge the money and don't deliver the stuff, right? So, and that's the same thing. Independently of if you have a business requirement or a technical requirement, if you can make a service long running, you get a better API. I'm really convinced of that by now. And then, just to make that clear, because that's important. If I say workflow, it doesn't mean I'm having some centralized workflow engine, some centralized whatever somewhere. It might be the case. There are advantages of that, but it doesn't have to be. I see it as an implementation detail of the microservice. So if like order probably also have a workflow, for example, for the overall order fulfillment orchestration logic, it has that. Payment has a separate workflow. They don't know from each other. They might use different workflow engines if they like. They might even hard code it. I wouldn't recommend that, but they could, right? So it's nothing really central. It's always an implementation detail of that one single microservice. That's an important thought. Good. So know what I call the BPMN monolith, what we saw in the past a lot, like doing workflows where you touch the responsibilities of different microservices, like, hey, if the credit card can't be charged, I update it. If the goods are not on stock, I reorder it. These are all responsibilities of different services. Don't do that. If you do that, you will end up with a workflow where you have to talk to all of these teams in order to change it. That's exactly what you don't want to do in microservices. But that's what a lot of people think of when I say workflows or BPM. Good. I have 4 minutes for my favorite topic, so I want to just scratch the surface there, but it's kind of connected. So if you look at transactions or consistency in these distributed systems, there's an awesome paper. It's from 2007, so it's a bit older already, but it's still very, very accurate. So I totally recommend to read that. From Pat Helland, at that time he worked at Amazon. Currently he's at Salesforce. He also was at Microsoft and a couple of others. He's quite a big thinker in the whole distributed system space. And he wrote about life beyond distributed transactions. And he basically explained why things like two-phase commit or X8 transactions, why there is nothing like distributed transactions. Technically, it's just not there. You can't leverage some technical infrastructure which magically does transactions for you in a distributed system. So if you want to have, and that's what most people think of when they say transactions, if they want to have two things in an all or nothing semantics, if that fails, I have to roll back that. You can't do that with begin transaction, commit, or rollback. It just doesn't work. So you have to think of different strategies. And one, it's not the only one, but one is what's very often referred to as the saga pattern, which is in BPMN called the compensation. So you could, same example, you could do something like, hey, I charged the credit card. That's what we already know. But let's assume we have, in the payment, we have the requirement that first we look at the customer account. Hey, probably he has money from some vouchers. So we deduct that first. And for the rest of the money, we deduct the credit card. Or we charge the credit card, right? And then if we can't do the credit card payment, and that's the inconsistency here, we still got money from his voucher, right? But we can't roll that back. That's a different microservice we talk to. It's a remote service. So what we do instead is kind of an undo. So the compensation activity, this one, it's kind of the, let's say, the business undo function we have to call when we compensate. And BPMN, for example, or the workflow engines can take care of that. It can say, hey, whenever this fails, I trigger the compensation, and then the workflow engine knows which activities it has to call this compensation activity. And again, it's stateful, so until it's really done and reliable. So that's quite powerful, actually. Right. And yeah, I'm always not sure if I can really give homework at conferences. Can I do that? Try to express that with a choreography, with a pure event-driven thing. You will end up with a couple of cycles and so on, but really try that. It's a good experiment. Send me the results. I'm always interested in that. Cool. And last thing about workflow engines, what I really believe in, what I saw at so many customers, is that having these pictures, not only for implementing things, but also during runtime, during operations. Hey, something is stuck here. Where does that come from? Why is that? It's not only a dead message somewhere down there in the messaging system, but you really see where it's coming from, what's the data attached, and so forth. You see a lot of statistics, so that's really, really valuable. Good. Yeah, and there are a couple of just quotes. I like that from Jimmy Floyd. 24-hour fitness. Do you know what a gym is? they're one of the biggest gyms in the US. And they're using that for a lot of integration flows. So you can see that here. They have around 21 million instances per day at that day. And they do everything via BPMN, which helps them a lot. So I think lightweight workflow engines are great. Far better than implementing the same stuff yourself, like a lot of times. Right, I'm almost done. Reality check, that's a slide from Zalando. They're using Kafka underneath. They're using Camunda to orchestrate things, so it's kind of related to what I showed here, so it's not totally artificial what I talked about. They do that for every order worldwide, so that's quite a bit. If you want to see code, there's a GitHub page where I have basically all the services I talked about really in code, so you can run it yourself using Kafka and Java and really play around with that. I have the choreography, I have the orchestration. If you don't get it to run, shoot me an email. So last slide, recap. Events decrease coupling, yes, for some of the communications, sometimes yes, but sometimes also not. So beware of doing only event-driven, that doesn't work. You have to balance choreography and orchestration, right? So orchestration needs to be avoided, not always. There are some reasons for that, but no ESBs, no smart infrastructure, but you need orchestration for some of the things. Workflow engines are painful only. Some of them, instead of doing it yourself, there are a lot of lightweight options available, which are quite interesting to look at. That's all I have. Thank you so much.